Hello everyone, welcome back to the classes. How are you all? I hope you all are good, you all are doing very well. So students, have you watched all of the sessions of this chapter about metals and non-metals that what we have discussed till now? That we have discussed about the chemical properties of the metals, chemical properties of non-metals. Then we have seen that what are the uses of the metals in the last session. So you have watched all of these session exactly, and whatever the question you are having or any doubt, so have you posted on the forum as well? Okay, so now it's your duty. You have to post your question, because after posting question, you will definitely getting your answers. Okay, so now we are going to continue with the same chapter, because we have left with some of the topics of the same chapter, but they are very easy. It's not like that they are very difficult, very simple. So the topics which we are going to cover in today's class is corrosion. Then we are going to see that what are the alloys, and then we'll see that what are the uses of the non-metals. Okay, so students, what the thing is that now we are going to study about corrosion. So, have you ever noticed, or have you ever seen that thing that the iron pipes, or if I say iron nails, or even though the body of our transport, like if we can say bicycles, bikes, and something like that, they are having some brown color layer over them. So, have you noticed that thing? Okay, so maybe some of them have noticed, or some of them not. So, students, what happened that when you look at that brown part, or that brown layer which has been formed over the surface of iron, that is called as the rusting, students, and that rusting is the corrosion. Now, what's the corrosion is exactly? So, what happens, student, when any of the metal is in the direct contact with the air and the moisture? So, there is the reaction between the metal and the air and moisture, and that's how, student, there is the formation of another compound, and due to that formation you can see that brown color layer over the metal, or if we generally talk about iron, so that we called as the corrosion. Corrosion means damaged, destroyed. So that's how your metal gets destroyed. So you can see here the eating up of metals by the action of air, that means oxygen, moisture, that means H2O, or a chemical such as an acid on their surface is called as the corrosion. For example, rusting of iron. So students, what happened that if I ask you to do one thing, that take one iron nail and you have to keep it in the open surrounding for almost one, or like more than 1 month, because it's a slow process. Corrosion is a slow process. So what happened that after some time, when you will going to observe it, you will definitely going to see that there is some brown color layer over that, brown reddish color layer. So what's that? Because the iron get corroded. Now how it is getting corrosion? Because when iron is in the contact with the oxygen and in the water which is present in the air, like surrounding or in the atmosphere, so there is the formation of the oxide, and that formation of the oxide layer over the iron results into the rust. So that is process is called as the corrosion, students. As you can see here that this is the iron chain. Okay, iron chain, and when you can see now at this point it is very much clear. Now it is neat and clean, nothing is there. When it is getting contact with oxygen and water, so you can see it is having some brown color layer over it. So when iron reacting with oxygen in the presence of water, so it form iron oxide. So what it is forming? It is forming iron oxide, and this we called as the rust. What we called it as? We called it as rust, student. And the rusting of iron is corrosion, because what happened that the iron has been eaten up by the air and moisture, because there is the formation of the brownish layer over it, that means the oxide layer over the iron. So that's how it gets corroded. And the corrosion of any metal with the, like in the presence of the air or moisture, we call it as the corrosion, or example is rusting of iron. So students, if you see here that iron is here and it is 3O2, so it is forming Fe2O3, and the water is like water is also there, fine, that is the whole formula of the rust. But if you can see, this is Fe2O3. So what you will observe here, that what it is getting formed here, students. So if you remember that when metal is reacting with the oxygen, so what it is forming? So obviously, student, iron is a metal, and when it is reacting with oxygen, so what it is forming? It is forming metal oxide. That means iron oxide it is forming. And see student, when it is forming this oxide, due to it there is some brown color layer that we called as rust. And even though, if you can notice one thing, that oxygen is adding to this iron, and students, addition of iron addition of oxygen is having one different name. Addition of oxygen, we call it as what? We call it as oxidation. So this is the oxidation process, student. Fine. So that's how you can see, when any of the metal was eaten up by by the action of air or moisture, or in the presence of the chemical substance, that is the acid. That's why student, we don't use acid with the metal, because metal will get corrode if it is having acid. That's why student, we don't store the pickles in the metal containers, because they can react with each other and they will form hydrogen gas over there. Exactly. So that's how, when there is a metal and when it is contact with any air or moisture or like a acid, so they will get corroded, or you can see that they are getting damaged or destroyed, and you will see some layer over their surface, and this is we called as corrosion. And corrosion, the one of the example is the rusting of iron, that when is in the contact with the oxygen and water, so there is a formation of reddish brown layer over it, that is the iron oxide, and that we called as the rusting of iron. And this is the whole process about corrosion. Now if I say that you can do one thing for, like, you can prevent corrosion, like you can prevent rusting of iron. So how you can prevent rusting of iron, students, that what could be the I can say preventions you can take. Okay, so let me add one thing here. Actually, I just forgot to do that. Just give me a minute. Okay, fine. So now I just want to tell you about the preventions, that how can you do the preventions preventions so that a rusting of iron will not take place. So the very first thing, student, that you can use paint, because now by using paint, what will happen, if this is iron sheet, fine, this is what, this is iron sheet, okay, and over this iron sheet you are doing some paint, I'll say red color paint you are doing, okay, this is red color paint. Now we know this thing, when iron comes in the contact of oxygen and the water, then it's get corroded. Now what we have to do is, we have to remove that contact. Exactly, like iron is there, oxygen is there, you have to remove the contact between these two. That means you have to insert something between them, so that oxygen and water is not getting direct contact with the iron. Okay, so what, that the very first point, that you can use paint. Why? If this is iron sheet, and over this iron sheet you are painting something, like with any color paint, I'm not talking about any specific paint, any color paint, so this paint will act as an insulator. Like how it is acting as an insulator, because paint is here, and oxygen and water will not come in direct contact with iron, because paint is there, so it will come in the contact with paint. So that's a student, your iron is not getting corroded, so you can use paint for that. Second, what you can do is that it is a very famous process which we call it as galvanization process. In galvanization process, students, what we do, that we deposit, in this case deposit the layer of zinc over, like on the iron sheet, or like on any iron material. So what will happen, student, like as we have seen that the oxygen is getting added with the iron. Now what will happen, the oxygen will get added up with the zinc and the iron will remain same. So that is the galvanization process, when you deposit the layer of zinc metal over the iron, so zinc will get oxidized, or we can say it will undergo oxidation, and iron will remain safe. So that's a student, as we have seen that the corrosion is a process in which, when the metal is in the direct contact with oxygen and water, then then it is getting corroded. Now you have to cut the contact between these, like it is iron and it is oxygen, and you have to cut the contact. That means you have to insert something at that point. So by like using paint or galvanization process and using oil also, so all such things will cut the contact between the metal and the oxygen and water. So that's how you can prevent the corrosion. So these preventions you can take, and that's how you can prevent, or you can save your iron from the corrosion. Fine. So that's how, this is the rusting of iron, and these are the preventions you can take to prevent the rusting of irons. Fine, students, I hope you got this point, what is corrosion, what is rusting of iron, and what could the precautions can we take. Okay, so this is the corrosion. Now moving towards alloys. Now what is the alloys? So alloys, a student, is something like it is a combination how it is a combination, like metal is combining together, or we can say that like metals and non-metals are also combining together. So when we get the combination of such thing, we call them as alloy. So an alloy is a combination of a metals or metals combined with one or more other elements. For example, combining the metallic element gold and copper products, copper produces red gold, like gold. And if you are adding it with copper, so you are getting in that case red gold. Okay, this is red gold. Now if it is silver and gold, so that means in that case you are getting white gold. That means students, you are adding up two elements or two metals together. So that's how student, when we combining metals or metals, then we are getting some combination, and from that combination we are getting some different properties. So that's how we prepare the alloys. Now for alloys, I'm having one video for you. So I'll just want you to show that video. Okay. I hope you will be liking that video.
Alloys. Alloy is a homogeneous mixture of a metal with other metals or non-metals. Alloys are used.
See, why she's saying that these are the homogeneous mixture. That means when you are mixing any metal with the metal or any other non-metal, so there is no such difference between them. It would be a homogeneous mixture that they are combining together to, and after that, like when you are getting alloy, after that you can't say that whether it is having which type of metal. Like if it is having metal or non-metal, you will be getting some different thing. So that's how you will not getting to know that by looking at that which metal is present in it. Okay, so that's why she's calling it as homogeneous mixture of metal with other metal or the non-metal. Fine, students? Okay.
Usually made by melting the main metal and then dissolving other substances in it. Alloys are made in order to harden the metals, change the color of metals, prevent corrosion, alter the reactivity of metals, and to improve the properties of metals. Properties of alloys. Alloys are usually stronger than the component metals. Alloying increases hardness. The thermal and electrical conductivities of alloys are lower than those of pure metals. Alloys are often more resistant to chemical decay than the pure metals. The melting point of an alloy is lower than that of its components.
So students, have you seen that what are the properties are like you can say exhibited by the alloys, that they are just similar, like they are having the metals and non-metals, but when they mix together, so they result in some different thing. So that's why there is a difference when we convert the metals and non-metals into the alloys. Fine. So when we are combining any metal to the metal or with the another non-metal and we are getting that mixture, so we call it as alloy, and we use these alloys at different condition. And it's just like student, for example, if you are preparing some alloy and you have to prepare the alloy with gold, so you have to first melt that gold and then you have to add the other substance, and when you are getting the mixture, so from that alloy you can prepare anything whatever you want. Okay, so that is the alloy, students. Now if we talk about like it is the alloy, so for alloy you don't have to be very specific or not very going to be detailed that what are the alloys. So it's just that they are the combination of metals or when they are combining with the another element as well, like they can combine with the non-metal as well, and you will be getting mixture, and that we call it as alloys. Fine. As you can see, some example has been written here, that combining the metallic elements gold and copper produces red gold, gold and silver becomes white gold, and silver combined with copper produces sterling silver. So these all are the examples of the alloys. Fine. Now we are going to see what are the uses of non-metals, that what we call as non-metals. So do you remember what are the non-metals? So if we talk about non-metals, so the non-metals are electronegative in nature. Like electronegative, how we are calling them as electronegatives, because they are gaining electrons. For example, chlorine, so chlorine will accept one electron and convert into Cl negative. If we talk about oxygen, oxygen will accept two electrons and convert into O2 negative. So that's how they are accepting the electrons and they are forming the anions. And students, if we see that the non-metals are usually what we have seen in their physical properties, they can either solid, they can be liquid, and they can be gases as well, that they can exist in three of the states. Like it's not only that for the solids we are having only solid one. So not for solid, actually I'm talking about metals, that they are solid in nature, but in non-metals we are having solid, liquid and gases, both type of like three type of state. Now what are the uses of non-metals? Fine. So first of all, if we see that in the non-metals there is oxygen. So now students, we know this thing, oxygen is very important for us. Why it is important? I hope I there is no need to tell you that why oxygen is important for us. Oxygen is very important for us because we, students, we need oxygen for the respiration process to inhale. If we are not getting oxygen, not only us, animals and plants, like all of the living beings required oxygen. So if they are not getting oxygen, even the plants required oxygen for their what, for their for their photosynthesis process or for complete respiration process. Exactly. So that's a student, every living being required oxygen. So oxygen, which is 21% by volume, helps in the respiration process, and oxygen we are having in our surroundings. So that is the main point or the main use of the non-metal. It is also used for manufacturing of steel and provides high temperature in metal fabrication process. Exactly, student, because adding of the non-metals, like we know this thing that the non-metals are usually having low melting point and boiling point, but when we add them for the metal fabrication, so they increase the temperature. Fine. So that's how metal containers or the metal utensils which we are using in our houses, even on cooking, like on heating them, they are not going to melt because they increase their temperature. Fine. So that's how student, we use these like the steel that is made up of non-metals only. Okay. Now non-metals used in fertilizers. See, fertilizers we use in the fields, like it is used by the farmers so that the fertility of the soil increases. So fertilizers are containing nitrogen, that is the fertilizer contain nitrogen, it helps in plant growth. So non-metals use, like you can say there is so much of usage of non-metals in the farming also, like for as the fertilizers. Okay. Non-metals used in crackers. Yes, crackers, like the which we use, like which we burn on Diwali. So it's like crackers, non-metals used in the formation of crackers as well. So these are the uses of the non-metals. But again, students, they have, like we have mentioned some of the here. But if I say that graphite is used in the like electricity purposes, for like some of the ways. And even the wood we are having, like it is also non-metal. So that's how student, we can see that we are having more usage of non-metals. Fine. Then diamond is used for the what purpose? That diamond is used for the mirror cutting. It is also used for the mirror cutting, and as well as diamond is used as the like for the ornaments as well, jewelry we can say. Diamond necklace, diamond ring, diamond earrings. So that's how we can see that non-metals are used up everywhere. And the very important one is the oxygen, that oxygen we require for respiration process. Okay. So these all are the uses of non-metals, but it's just that like it is not limited that only these are the uses. Even though if any use you know, so you can also write in your exam. Fine. So these are the uses of non-metals. Now if we see what the question is here, which non-metal is mostly used for making crackers? So the answer for this question, student, it is sulfur. Sulfur is used for making crackers. Okay, so the answer is correct. So, students, what we have revised in this session, as it is a simple small session because all of the topics are very simple, that we have seen that what is corrosion. So the corrosion is a process in which metal is getting destroyed or damaged, or we can say it is eaten up by the air and moisture and acid. For example, if I ask you, will you be able to store a pickle, lemon pickle in aluminium utensil? If you remember this question from the last session only, like will you be able to do that? Exactly, no, because metal is getting corroded by acid. So there will be more, there like more toxic substance may get formed, and it is not good for our health. Exactly. So the corrosion is a process in which metal is getting destroyed, or you can say damaged or eaten up by the air or moisture, and you can see there is some formation of layer over their surface. That is why we call it as corrosion. And the corrosion example, you can see it is rusting of iron. And in rusting of iron, what we have seen, that iron reacts with oxygen and water and form rust. But exactly we are getting what? Metal oxide, that is iron oxide. And the that means oxygen is getting into the iron. And addition of oxygen, student, we call it as oxidation process. That means the oxidation of iron result into the rusting. Fine, so it result into the rusting. Now we have to break that rusting. That means we have to break that contact between oxygen and water. So what preventions you can take? Like you can use paint, you can do galvanization so that there will be no contact between them. Fine, so that's the preventions. Now alloys, that alloys is the combination of metals or metals and non-metals. So that's how we are getting the different kind of thing from that. Okay, uses of non-metals we have already discussed. So it's like a very simple thing to discuss about the usage of non-metals. Then it is the question that they have asked us, that which non-metal is mostly used for making crackers. So the sulfur is the answer. Now that means we have completed with our session, like today's session, and with that we have completed with the chapter also. We have done each and every part of this chapter. Now it's your duty to watch all of the session carefully and now complete your chapter. And if you're having any doubt, any question, you can post your question on public or private forum of Ask IITians. And as I've told you, you will be getting your answer from expert side. And it's just that you have to study well, clear your concept, learn each and every reaction of metals and non-metals, that how they are reacting, what is reactivity series, and you will be having a complete package of this chapter. So just revise it very well. Fine. So in just last, like what I want to say, that thank you so much for watching the session and keep learning from Ask IITians. Thank you.